All right, so let's pick up where we left off. All right, now let's do square root. So the parent square root looks like this. This guy, since it's inside, is plus 4, so we're just going to go left 4. 1, 2, 3, 4. Looks like that. Okay, here, first let's draw the parent. Looks like that. And then let's draw the transformation. So here he's going to go down 4, and it's inside. There's a negative sign, so he's going to reflect the x-axis. First, let's go down 4. 4. And instead of turning that way, we're going to turn this way. So that's what it means to reflect. All right, here, the normal absolute value is like this. And then a 1/2 in front makes it going to get wider, or you could say stretch. Right, so it's like that. Just draw something that's wider. I'm going to do the next problem, and then I'm going to combine them to show you something. And now we have 4x. So the traditional, the parent function for absolute value is this. 4x is going to make it shrink or get skinny, however you want to think about it. So he's going to look like this guy. And I want to show you on the graphing calculator. Y equals, all right, to do absolute value, okay, on your buttons, you're going to click math. And then go over to CPX, go down to ABS, that means absolute value. And then we'll type in X, close parentheses. That's absolute value. Okay, here, I'm going to do that 1/2 absolute value. And then I'm going to do the 4 absolute value. All right, so those are the 3. Right, that's absolute value. That's 1/2 absolute value. And that's 4 absolute value of X. So notice the difference. And so don't stress like, oh my gosh, I can't remember. You can use your calculator as a resource. Right here, cubed root is like this. The vertex still being right there. And so this says we're going to go up 3 from that. And then we're going to go not left 4, but right 4. So up 3, right 4, 4. And then we'll still draw the same shape. Okay, here, the parent function is this guy. And then we're going to go down 2 from that, -2, and we're going to go left 5 from that, +5 on the inside. So down 2, left 5. And then draw the same basic shape. Right here, we have 2 graphs, and we need to figure out the equation for that graph. So let's talk it through. So this is x squared. All right, we see it's reflected on the x, so it turns down. We see that it moved left 4, so that means on the inside it's going to be a +4, and it didn't move up or down. So we're going to write g of x equals, reflect on the x-axis makes a negative on the outside. Then we have an x plus that 4 squared. And so that's our equation. Let's do another one like that. here we have square root of x. And so this guy, he went right 2, so there needs to be a plus 2 on the outside. And then he went, on the inside, not a plus 2 on the inside, it needs to be a minus 2 on the inside. And then he went up 2, so then it needs to be a plus 2 on the outside. And then he turns the opposite direction, so he reflects. There needs to be a negative on the outside. And it's a square root, so I'll put square root, that's g of x, negative on the outside, plus 2 on the outside, there's an x in there, and then a minus 2 on the inside. That's how we put it all together. Not too bad. All right, and then let's talk about your project. Okay, so I've kind of reviewed all the different functions. In the next video, I'm going to review piecewise. And just have a cover. The graphic organizer can be this guy. Just fix this piece. Or you can make your own, get your own, if you don't like mine or if you don't understand mine. And then you go through each function. And so don't overthink this. I just want real life examples. So a real life example of a linear function could be the side of a desk. Could be your arm going like this. It could be, my glasses right here. An absolute value function could be your hands going like this. It could be the corner of a desk makes a V. Quadratic function is a U. It could be the side of your mouth. The cubic function, you could find like a river that makes that shape. Square root function, like a guy throwing a basketball or like a baseball that their hand makes that shape. So don't overthink this. All right, and so I want the name of the function, exponential function, and then kind of describe their shape. So the exponential function is like this. So you could say like it goes through 0, 1, and their shape, and you draw the little shape, and you say the parent function is some number to the x, or some base to the x for exponential. And then you just need 2 real world examples. So go to Google. I'm in Google right now. Exponential function and real life example. That's what I typed. Okay. And then I'm going to go to images. Okay. This came up. There you go. See that shape right there? There we go. Sounds great. So then you, or like related images, okay? There's a quadratic. There's absolute value. Another quadratic and linear. Quadratic. And so you literally look up the function name in real life and then find a picture, okay? And so like you find a picture like here and you just either put it on a Word, like print it out, or put it in Word or Paint or something, and then literally just highlight where that function is. So I know that you know the shape. You do not have to find the equation. I just want the highlighted function. So like here on quadratic, like the way the ball is going to move is a quadratic, or the wave right here is quadratic. Right, for piecewise, I'm going to explain piecewise functions in the next video, but since I'm explaining your project right now, I want to show you. So a piecewise function is pieces of different functions. And so like this volleyball one is a good example. So like right here is quadratic. Okay, right here is linear. Right here is absolute value. Okay, so there's pieces of different functions all in there. This guy right here it could be a piece of a rational function, it could be a piece of a square root function, it could be a piece of an exponential function. These right here, that and that on her hips are pieces of a rational function. And so you're just taking pictures that look like the shapes of your functions. So don't overthink that. And so hopefully that'll help you with your project. Right, so go do your practice work on transformation of functions, and hopefully the help that I gave you for your project will work. If not, you can text me or email me. I'm here. Bye.